Hello students, welcome to Physics Made Simple, that is PMS. I am Professor Milind Kulkarni. I am dealing in physics about last 20 plus years. I am trying to educate you in physics and not literate you in physics. Now what is physics as such? The science that deals with the study of natural phenomena and the principles behind it, it is called as the physics. It is called as physics. Now, what are the different, if we see the natural phenomena, that is say rainbow, say raining, say why it is lightning, why it is thundering, why it is other phenomena in the nature, what is the basic principle behind them, that is what we try to study in physics. Now you know that the nature is made up of basically the matter, the energy and the other things. Now this matter, that is whether it is living or non-living, this matter is interacting with energy with at all levels, possible levels, from a small micro molecule to the infinitely large universe. So if we want to study the physics, what we say is, it is the science that deals with the natural phenomena and the basic principles behind it, that is called what is called as a physics. This is what we have started. Now we have, in that case we have defined, that is, it is the matter and energy. So another definition of physics, you can say that the branch of science that deals with the natural phenomena, including the interactions between the matter and energy at all possible levels from micro to macro extent, that is called as a physics. Now this is the definition of physics. Basically, that is, it is the matter and energy and its interactions with each other. Now what is the scope of the physics, or what are the different branches of physics as such? Now when we are talking about the physics, it is basically there are n number of branches of physics with which we can deal. Say for example, there is the mechanics, in which we study about the laws of motion, we study about the forces, we study about the energy, that is the mechanics. Then we have acousticism, that is the branch of physics that deals with the sound, the techniques of sound, etc. Then we have the thermodynamics, that is the branch of physics that dealing with the thermal changes in the nature, that is the dynamics means changing, thermo means the heat, energy. So the branch of physics that is dealing with the changes in the energy is called as thermodynamics. There is a branch of physics which we call as electrostatics. Static means stationary. So the branch of physics that deals with the stationary electrical charges, that is called as electrostatics. The branch of physics that deals with the moving charges, we call it as current electricity. Then we have the magnetism, because whenever the charges are moving, they produce the magnetic field. That means there must be certain interaction between the electric current or the current electricity and the magnetism, which led to the foundations of Faraday's laws of magnetism and the electromagnetic inductions as such. Then we have the magnetism, then we have the modern physics. In this modern physics, we study at a micro level, that is the atomic level, that is what we study in the atomic physics. We study nuclear physics, we study cosmic physics, we study majority of the physics branches. Then we can see the objects in the nature because of light. The branch of physics that deals with the light, it is called as optics. The branch of physics that deals with the light is called as optics. Now, the light has got a dual nature. It may be a particle or it may be in the form of a wave. So, we have the wave optics as well as the ray optics. Then we have the nuclear physics in which we are dealing with the atom, the nuclear reactions like your radioactivity, that is nuclear fusion, nuclear fission reaction, study of nuclear reactors, study of atom bombs, etc. Then we have the cosmic physics, we have radio physics, we have various branches of physics. That it means that from every part of a life or in every part of your life you require a physics. Now, as a science student, you have the two possibilities or you have thought of only two openings, either engineering or you have thought of a medicine. Of course, there are the graduation courses, undergraduation, post-graduation courses in almost every branch of physics, or you can say, for that matter, every branch of science. Now, if we are talking about the physics and if we confine our introduction to the process of engineering or the study of engineering and the study of medicine, then you have, as a science student, you have two openings. One is engineering and the other is medicine. Now, when you are talking about the engineering or medicine, in engineering, your combination is PCM, that is physics, chemistry and mathematics. Now, in medicine, you have PCB, that is physics, chemistry and biology. Now, whether you go for engineering or whether you go for medicine, you ultimately have to study the physics essentially in either of the branches. Now, see, for example, when we are constructing the roads, in the construction of road, we are using the principles of elasticity, we are using the principles of physics, what should be the slope, how the gradient should be, everything that is related to the physics. And the construction of the bridge, the construction of buildings, everything that is the branch of engineering, that is the structural engineering or the architectural engineering. So there you have to study the physics. Now, physics and mathematics, they go hand in hand. We have defined physics as the study of interaction of matter and energy at all possible levels is called as the physics. Now, the interrelation between this energy and the matter, or these interrelations, they are given in the form of physics formulae, which are the mathematical forms of these interrelations. So, in physics, you are not only going to study the classical physics, but also to some extent the mathematics as well. So, it is said that mathematics is the language of physics. Mathematics is the language of physics, and therefore we have to study in engineering physics as well as mathematics. Now, say for example, the physics engineering, I am going for software engineering where I am going to study with solid state physics, that is the diodes, triodes, that is the semiconductors and all other things, or in any other branch where I am going to deal with the physics, that is in case of engineering, I can understand, or people may talk that the physics is the most essential and the core subject in engineering branch. Fine, well, accept, agree. What about the role of physics in medicine? When I go to my doctor and if I tell him that doctor, I am suffering from this and XYZ disease. Now, I am not talking about chromosomes when I am talking X, Y and Z. It is something blah blah disease. Then, if he asked me what was your blood pressure, what was your intake fluid, what was your CBC rating, what was your ESR rating, what all these things mean? You know that CBC is the total blood count. That is, then in ESR you have to use the erythrocyte sedimentation rate. That is including the physics. Fine, my stool report is normal, my blood report is normal, my ESR report is normal. Then, still I am suffering. Then what the doctors say? Go for X-ray. If I go for X-ray, for taking the X-ray, the technique used, it may appear very simple, a black film on which my particular XY part is taken on it. Then it is the X-ray which is based on again the principles of physics. Of course, that to be a doctor, you need not have to know the X-ray, how it is taken, what way it is taken, but for what it is taken, you should know, that is PA view, CA view and all those things. Then when you are talking about the heart problems, the basic thing you are doing is ECG, that is electrocardiogram. When you are taking your electrocardiogram, the pulse rates are, or the heartbeats are plotted in various things, that is in systolic form, in diastolic form, and that is again the graphical representation, how your heart is beating in a particular intervals, that is what is noted. It is based on what? Again the principle of physics. Then your sodium and potassium intake, it is also based on physics. Then we are talking about encephalogram, that is the brain fever. That is when a person is suffering from a brain fever or the disorders of the brains, we have to consider the encephalogram. That is it is similar to the cardiologist or it is similar to the ECG, but it is the pulses or how the brain is functioning at a particular interval or at a particular instance, that is graphically maintained, and that is known as electrocardiogram. That is, if you go to simple optician, I can't see the things properly, so I go to optician. I don't know whether I am suffering from short-sightedness, I am suffering from long-sightedness, or whatever the X disease I am having, or the alterations in my eye I am having. For that purpose, I go to my optician, and the optician checks out he says that it is a computerized eye testing. Now, from where the computer has came? It is the origin, its origin lies in physics, and using that physics principles, what you are testing? Your biological system, that is your eye, heart, brain, kidney, eye, all these things can be tested by using the physics, that is the principles of physics in your body system, that is the biological system. So though you are going to be a doctor and you are not going to do all these things on your own as a single person as such, but it is needed. It is needed. So the scope of physics, the value of physics or the study of physics is as well essential in the fields of medicine as well. In the fields of medicine as well. Now, when you are talking about the centrifuge machine, that centrifuge machine which we use in biological labs and or in chemistry labs, that has come from where? It has come from the physics. That is the centrifuge force or the centrifugal force and the centrifuge force, and on that basis it is working. The simple mixer and grinder in our house, it is also working on what? It is also working on the circular motion. So it is again a physics. It is again a physics. When you check the pulse or when you check the pulse rate of a person, you measure the counts of the pulses. That is, it is as if the heart is making the oscillatory motion, that is the pumping and relaxation, that is systolic and diastolic. So it is every time, it is rhythm, its rhythm is maintained same. It is again the physics phenomena. So coming back, the physics plays an important role in your every part of your life. When you are driving a car, when you are driving a four-wheeler, and suddenly you apply the brakes. The brakes you are applying, when you apply the brakes, all the four wheels of the car come to the rest at one single point. It never happens that the front wheel has stopped and the rear wheels, they are moving. Now this is again based on what? The principles of fluids. So fluid mechanism, fluid mechanics. Okay, so that is the Pascal's law of fluids. That is on what the hydraulic brakes are working. So it is everywhere, in every part of your life, the physics is essential. And hence my sincere request to you is that you must focus on physics, you must concentrate on physics and keep studying physics, enjoy it. If you fall in love with physics, you will never fall in love with any other thing. So enjoy studying physics. Thank you very much. किती मिनिटाचं झालं?